Hey guys, welcome to 2014 Level 2 Calculus exam walkthrough. In this video, I'm going to be walking through the 2014 Level 2 Calculus exam. So get straight into it. A function g is given by g of x equals to x cubed minus 4x plus 5. Find the gradient of the graph of g at the point where x equals to 2. So finding the gradient of a graph means we need to find the gradient function, which means we need to find the derivative, okay? So therefore, g dash of x that equals to 3x squared minus 4. To find the gradient at the point where x equals to 2, all we have to do is find, substitute 2 into the equation. So g dash of 2 equals to 2 squared minus 4. G dash of 2 therefore equals to 2 squared is 4, 4 times 3 is 12, 12 minus 4, which is 8. So 8 should be your final answer there. And this is just simply an achieved question there. Alright, next question. For a function f dash of x equals to 3x squared plus 4x minus 1, the graph of f passes through the point 2, 5. Find the equation of function f. Alright, so we have now this time we're given the gradient function or the derivative, and we're expected to work backwards to find what our function was, okay? So in this case, we're not going to be differentiating, we're going to be integrating. So this time, so f of x equals 2. So you increase the power, then you divide by the new power. So 3x cubed divided by 3 plus 4x squared divided by 2 minus x plus c. So f of x equals to x cubed plus 2x squared minus x plus c. They pass through the point 2, 5, so I'm going to substitute y equals to 5 and x equals to 2. That's 8 plus 8 minus 2 plus c. 5 equals to 16, 14, 14 plus c. C therefore equals to negative 9. So therefore, f of x equals to x cubed plus 2x squared minus x minus 9. And that again is just an achieved question there. Two easy achieved questions to start. Question C. A diver dives into a pool. The depth, d meters, as she reaches d seconds after she hits the water is given by d of t equals to 1.25t squared plus 4t, minus 4t. Find the greatest depth that she reaches. To find the greatest depth, that's basically asking us to find a maximum, okay? To find a maximum, we need to find the derivative and set the gradient equals to 0. Because at the maximum, at the turning point, there was a moment in time where the gradient equals to 0. So therefore, we get our d dash of t. We're going to differentiate, so that becomes 2.5t minus 4. We're going to substitute our gradient equals to 0, and we're going to find when is t. So I'm going to find what our t value will be. So 4 equals to 2.5t. So 4 divided by 2.5 is what we're trying to find. That gives you t equals to 1.6 seconds. But we're not quite done yet because we need to find the greatest depth that she reaches. Not what time it takes for her to reach the greatest depth, okay? So what we have to do now is substitute t equals to 1.6 into our distance formula, okay? So d of 1.6 equals to 1.25 times 1.6 to the power of 2 minus 1.6 times 4. All we need to do is plug this one into our calculator. So 1.6 squared minus so it should come out to be equals to negative 3.2 meters, okay? Yeah, that's the right answer, and that actually will give you a merit grade. To get an achieved grade, you're looking at finding t equals to 1.6. So finding your t equals to 1.6 correctly will get you an achieved grade. Next question. The graph of f of x equals to negative x squared plus kx minus 5 has a turning point at 3, 4. Find the gradient of the function at the point where x equals to 4. Alright, so once again, we'll find the gradient of a function where x equals to 4. Alright, so first thing we've got to do is got to differentiate to find a gradient function, okay? So f dash of x equals to negative 2x plus k minus 5. Alright, so now the first thing we've got to do is got to find what our k value is. That's really easy because it says there's a turning point at 3, 4. So when x equals to 3, our gradient equals to 0 because it's a turning point, and our turning point gradient is 0. So we simply substitute x equals to 3 and our gradient equals to 0. We can simply figure out what our k value is. So 0 equals to negative 2 times of 3 plus k minus 5. 0 equals to negative 6 plus k minus 5. Therefore, we can figure out that k is actually 11. Okay, we found out that k no, actually it's not 11. No, the negative 5 is gone. Sorry, what am I doing? I'm being stupid. Sorry, it's just negative 2x minus k plus k. So the plus 5 is gone actually. So therefore k is actually 6. Sorry about that, guys. Basic mistakes. So k equals to 6, okay? So now we can rewrite our f dash of x. So f dash of x equals to negative 2x plus 6, okay? So that's our gradient function. And now we need to find the gradient at the point where x equals to 4. So now we substitute our x equals to 4. So f dash of 4 equals to negative 8 plus 6, which equals to negative 2. So negative 2, that should be your final answer, and that will give you your merit grade. To get an achieved grade, you're looking for k equals to 6. That's an achieved. Alright, moving along. G of x equals to 2x cubed divided by 3 plus 3x squared divided by 2 minus 20x plus 4. For what values of x is g a decreasing function? Alright, when it says decreasing function, that means the gradient is less than 0 because it's decreasing. So over time, it's going to decrease. Over as x increases, our y value increases, or our g value decreases. So we need to find what g dash of x is. So our g dash of x, so 2 over 3 times 3, so that's 6 over 3 of x squared plus 6 over 2 of x minus 20. So g dash of x should give us 2x squared plus 3x minus 20. What values of x is g a decreasing function? So 2x squared plus 3x minus 20 gives us a value that's less than 0. Alright, so now we're going to factorize if we can. We should be able to. Factorize negative 10. Sorry, this might take a bit of a while. Algebra skills are rusty. Plus 5. Okay, it should be plus 4 and minus 5 if I'm not mistaken. Let me double check that. Plus 8. Yeah, that's correct. That is less than 0. So therefore x is equal to 2.5 or x equals to negative 4. However, we need to find for when it's less than 0, okay? 2x squared, that's a normal parabola, that's a positive parabola, so the shape's going to look something like this. We have our 2.5 on this side, and we have our negative 4 on this side. That's when it's equal to 0. We need to find for when it's less than 0, so it's in between these two values. So we're going to write our x values as x is less than 2.5, but x will be more than negative 4. So therefore, x is in between negative 4 and 2.5. That is your final answer. Getting that correct, okay, that should give you your excellence grade if you can get up to the last bit of the question. So reading correctly, to get a merit grade, you're looking at finding the derivative and the x values. So finding your x values, yeah, that's right. Finding these x values here will get you a merit grade, and to get an achieved, you're finding your derivative right here. That's an achieved. Right, moving along. During a fundraising cycle ride, the distance s kilometers of a cyclist from a fixed point on his ride is modeled by the function s of t equals to 0.1875 t cubed minus 2.25 t squared plus 21t plus 0.5, where t is the time in hours since the cyclist passed a fixed point. How far will the cyclist be from the fixed point when he reaches his minimum speed? Alright, so read the question when it's finding the minimum speed, okay? So first we need to find what our velocity formula is, and then we need to differentiate our velocity formula to find the gradient function for our velocity formula, and then we substitute the gradient equals to 0, and then we can use that to find the minimum velocity, and then we use that, so we find the time that it reaches, the time it takes for him to reach the minimum speed, And then we'll substitute that time back into our S of t. So that's the abbreviation. I am very sexy. Okay, we can use this abbreviation. So A is acceleration, V is velocity, and S is distance. Okay, so to go from S to V, we need to differentiate. Okay, so we differentiate our function. So V of t equals to, we need a bit of calculator. 0.175. Sorry. 1.805 times 3. 0.5625 of t squared minus 4.5t plus 21. That's our v of t. However, we need to find the gradient function for our velocity formula to find the minimum speed, because the minimum speed only happens when the gradient is 0. Okay, so our v dash of t, that will give us, we need to differentiate again. So that gives us 1.125 of t minus 4.5. And now we need to find what our t value is for when the gradient is 0. So we substitute the gradient is 0, and we'll find what our t value is. If you evaluate the t value, okay, the t value you should evaluate as 0.25 should be your evaluated t value. Is it? No, it's hours. Okay, so t equals to 0.25 hours. Okay, and now we're gonna substitute the 0.25 hours back. No, it's not 0.25 hours. It's 4, isn't it? It's 4, isn't it, Kevin? Sorry, I'm being really stupid today. 4.5 equals to 1.125 t. Yeah, it is 4, guys. Sorry about that. That's 2 mistakes I've made now. Sorry about that, guys. That's really silly. That shouldn't be a... T is actually equal to 4 hours. So we just need to substitute V, not V of 4. S of 4 to find our distance. Alright, so now we just need to do a bit of math, okay? So and plus that will evaluate to 60.25. Minimum how far? So the distance is measured in s kilometers, so the unit will be 60.5 kilometers. That will be your final answer, and that will get you your excellence grade. Yeah, sorry about that t equals to 0.25 confusion. That's just me being silly. Sorry about that, guys. That's really not acceptable, but sorry. To get a merit grade, okay, you're looking at acceleration found and set equal to 0. So if you can find your v of t and set it equal to 0, that's this here, that'll get you a merit grade. And to get an achieved grade, you're finding the correct velocity equations. V of t found will get you an achieved. Next question. Question 2. The graph of the function f of x is shown on the axis below. On the axis below, sketch the gradient function of y equals to f dash of x. Alright, so our turning point, okay, is at -3. So therefore, when x for our linear graph, it's going to differentiate into a linear graph. So when our linear graph, so when x equals to -3, our gradient will be 0. So it's going to pass through this point, which is -3, 0. This is a negative parabola. So when x is less than -3, the gradient is positive, and when x is greater than -3, the gradient starts decreasing. Sorry, not negative, not necessarily negative, but it starts increasing. Okay. So the way we're gonna draw this is so when x is less than -3, our gradient is increasing. So our gradient should be above the x-axis. Okay, so should be just somewhere here. Our gradient is above the x-axis. And after -3, so after -3, if it's greater than -3, our gradient starts sloping downwards. So it should be less than negative 3. So we're just going to, for example, plot there. And all we need to do now is just to join the line through these points. And that we can call is our linear, we can call our linear function for f dash of x. So that's all you need to do, and that's just an achieved grade there. Yeah. Alright, the graph of the function y equals to g of x passes through 0, 0, and its gradient function is g dash of x equals to 2x minus 5. Find the y coordinate on the point where x equals to 3. So, g of x passes through 0, 0, and its gradient function is g dash of x is 2x minus 5. So we need to go back to the function, so we need to integrate. So that will simply become x squared minus 5x plus c. Passes through 0, 0, so therefore when y is 0, x is 0. Therefore our c value is also 0. So g dash of x equals to x squared minus 5x plus c. Find the y coordinate of the point where x equals to 3. So now all we need to do is to substitute 3 into our formula. And that equals to negative 6. Again, that's only just an achieved question. Sion claims that the resale value of a car t years after it is sold can be modeled by the function r equals to 150t squared minus 2,250t plus 38,000, where r is the resale value in dollars. How long after it is sold will the car's value begin changing at a rate of negative $150 per year? So that when it says changing at a rate of something, that's basically just mean each year the car's going to lose $150 in value. So therefore, the gradient will be negative 150. First thing to do, once again, something to do with gradient, we're going to differentiate. So dr over dt, that equals to 300t minus 2,250. So how long after they're sold will the gradient be negative 150? So substitute our gradient equals to 150. If we move the 2,250 to the other side, it will actually become 2,100 equals to 300t. And therefore you should be evaluating that your t should be equal to 7. And that's all you have to do. And t equals to 7 here will get you a merit grade. And to get an achieved grade, you're finding the derivative and setting it to negative 150. So getting up to here will get you an achieved. Alright. A gradient function h dash of x is shown on the axis below. Sketch the function h of x if h of x passes through the point negative 3, 2. First thing to do in these questions, mark the point that it needs to pass through. So negative 3, 2. So negative 3, 2. So it needs to pass through. It needs to be passing through negative 3, 2. It needs to pass through this point. Always mark the point that it needs to pass through. Alright, next you have to evaluate your x-intercepts. Your x-intercepts are at negative 3 and what is that point? That should be 2.5. That's where your x-intercepts are. So you need to mark where your turning points have to be. So your turning points have to be at x equals to negative 3 and 2.5. Okay? And now, basically, you need to have a correct shape for your cubic graph. So how are you going to find the correct shape? Okay, so as you can see, when x is less than negative 3, we have a okay, the first thing you can tell is that this is a negative parabola, so therefore you have a negative cubic, okay? So therefore your cubic should look something like this. So you're gonna have your negative turning point first, and then you'll have a positive turning point. Alright, so basically notice that our turning point occurs at the same point as our point of negative 3, 2. So therefore, our turning point should also be this point. Okay. Basically, they give you the turning point. Okay. Okay. So when x is less than, so coming back to our parabola, when x is less than negative 3, we have a gradient that is less than 0. However, as x is between negative 3 and 2.5, there's a positive gradient. And if x is more than 2.5, once again, the gradient becomes negative, okay? So first of all, the graph's going to be decreasing, okay? It's going to start here, it's going to start decreasing. It's going to hit our turning point, which is negative 3, and then it's going to start having a positive. So that's this point here. now it's going to start having the positive gradient. So it's going to start, this is a turning point, and it's going to start sloping up. And then it's going to, it's going to keep having a positive gradient, and it's going to then, and then it's going to keep having the positive gradient until it reaches x equals to 2.5. When x equals to 2.5, it's going to hit another turning point, and then it's going to start coming back down again. And that should be the approximate shape of our cubic. Okay? So basically, you have your turning point at the correct places. So turning point at x equals to 2.5, correct turning point at x equals to -3. And basically, just in terms of the other things, you just need to have a correct shape. So minimum at -3, 2, correct, yeah. And the second turning point indicated in the range, yeah, that's correct, okay? So that's all you really need. It doesn't have to be very precise. Just what I've drawn here would be enough to get you your merit grade. To get an achieved grade, okay, you're looking at, so either you have your turning point, at this point here, or you can have your turning point at in between 2 and 3, and that either one of those will get you an achieved. Alright, and you need to have it in the shape of a negative cubic. That's a must. Alright, moving along. The gradient of the graph of a function is given by dy over dx equals to 9x minus 3x squared. At the maximum turning point of the graph of the function, y equals to -4. Find the equation of the graph. At the maximum turning point, the graph of the function, y equals to -4. So at a maximum or minimum turning point, the gradient equals to 0, like we've established. So we're going to substitute our gradient equals to 0 to find out x values. So 0 is, we'll take the 3x out, so that will leave us with 3 minus x. Yeah, 3 minus x, and therefore x either equals to 0 or x equals to 3. Now we need to find which one's the maximum turning point and which one's the minimum turning point. So basically d squared y over dx squared, so the second derivative, that will give us 9 minus 6x, okay? And 9 minus 6x, and now we need to substitute and see which one will give us our maximum turning point and which one will give us our minimum turning point. So we substitute x equals to 0, so if we say 9, if we substitute 9 minus 6, that will give 9 minus 6 times 0, that will give us 9. 9 is positive, therefore this is the minimum. If we substitute our 3 into the equation, so that will be 9 minus 6 times 3. That will give us -9. This is negative, so therefore this is our maximum that we need. So now that we proved that when x equals to 3, that is our maximum, we can now integrate. So now we can say that our y equals to 9x squared divided by 2 minus 3x cubed divided by 3 plus c. So y equals to 4.5x squared minus x cubed plus c. Alright, so now we substitute our now we substitute the turning point. It tells you the y value is -4, and then it tells you that's when x equals to 3. So just substitute 4 and 3 into the equation, and you should be able to find your c value. And that should come out as -17.5, but I'll just double check. Sorry, 9 times 4.5 minus cubed. Yeah, that should give us 4 equals to 13.5 plus c. Sorry, -4. -4, so therefore -17.5 equals to c. So therefore our y equals to 4.5x squared minus x cubed minus 17.5. That is our final answer. And getting all the way up to there will get you your excellence grade. To get your merit grade, you're looking at maximum turning point at x equals to 3 justified. So you find your x equals to 3 and then you prove it with the second derivative test. That'll get you your merit. To get an achieved grade, you're looking at x values identified in the turning point. So x equals to 0 and x equals to 3 will get you an achieved.